So previous class end here, derivation of thin lens formula 1 by minus u plus 1 by v, that is equal to 1 by f. And here now discuss convex lens, and convex lens how to create an image, and that image is real or virtual. Okay, so creation of the image with the help of convex lens, and that is a convex lens here. So next page, that is a convex lens, and that is a convex lens. That's the principal axis, and here that is called a focus, and that is a second focus. Here that is from pole, okay, and that distance from focal length pole to focus, and same as here as the focus, there is a focal length, okay, this distance similar as this distance from pole to focus, and here is twice of the focal length, okay, and this point is another name is called C, the center of curvature. Okay, if the object standing on second focus or called center of curvature point, okay, so that so these are called source to parallel to principal axis, that there is an incident ray fall on convex lens, this surface. So after striking, now this ray, refracted ray passing from, okay, these are called this ray, okay, after striking of convex ray, convex lens, the incident ray, convex lens, and that's the refracted. Actually there is a refracted, and here is the emergent ray passing from that focus, okay, and we need another point, another cutting point here, so that incident ray, if you fall on pole, so do not deviate, so, okay, so actually the passing from here, and here we meet the two cut point here, okay, so if a two cut point, that's enough. So here you see that there's a u, the object distance from pole to center of curvature, and from pole to here, that this set of center of curvature, there's a create image, and that is actually the image is inverted, and that is a v, that is the image distance, that is the object distance, that's the image distance, okay, and here you see the very carefully, that's the height of object, that's the height of image, and see that this ray actually meet a point. This ray, actually there is an emergent ray from lens, actually meet a point. Okay, if they actually meet a point, okay, so this image is called real image. They actually meet a point. Okay, so the magnification, that is equal to height of the image by height of the object. So an image is the minus, so minus negative direction. So and similar case at that is v by u, and you also say that u is negative x direction and v is the positive x direction, okay, and this image is real image, okay. And now if I draw an image in concave lens, concave lens, concave lens, and now lens is look like this. There's the principal axis, and that is called focus, suppose the center of curvature, second focus, okay, and if that object standing on center of curvature or point C, so that's the incident ray. So after striking that ray, emergent ray from the lens, there is a diverge here, so if the diverge, so that's why there is a back point here, back to the passing through that focus, and now we need another point, so at that point is a pole, okay, that's a divergent here, and you see that these two emergent rays do not meet actually, but you have backward here, that you see that is midpoint, but in reality there is a dot, a backward line, and the midpoint here, and here that is an image. Okay, and image size is smaller than object, and that image is not actually meet, but they appear to be meet. Okay, these ray to be appear to be meet, but that's it. Okay, they appear to be meet, so that's why this image is a virtual image, appear to be. And the magnification formula, height of the image. Okay, these are the height of the image, h dash, and height of the object is h dash by h, and both be the positive, and same as v by u, both be the minus left side, that the u object distance, or this is object, and that is a v image distance, both be minus, so minus v by minus u, so cancel v by u, and here the image is virtual image. Okay, actually both lenses, I think concave and convex lens, both lenses create that the real image and also virtual image, but depending where the object is placed. Okay, where the object is placed, that's the main concern, and the creation of the image. In that case here they actually meet, so that's why it is a real image. Actually they are not actually meet, but they appear. If I draw an imaginary line, this is a back imaginary line, and I see that a cut point. So that's these if I draw imaginary line, so that's a virtual image. Okay, clear what is a real image and what is a virtual image. And in case of two types of lens, convex and concave lens. Now we discuss another important concept is a power of lens. There is a power of lens. So what is the power of lens? That's a very important concept. When you visit the eye specialist, doctor said after examine you have a plus power or you have a say minus power. What is signified for plus power and what is signified the minus power? What lens doctor suggests? After discussion the power of lens, and you know that what power is signified, what the plus power is signified, which lens, and what is the minus power signified and which lens also signified. Okay, so now we discuss the power of lens. So what is the power means? Here we suppose say there is a convex lens and that's the principal axis, and here is the object here, and that's the incident ray after focus, and that distance from pole to focus is called focal length. And you see that very carefully, this angle and this angle be the same, because if I extend this, if suppose there is no if I did no lens here, so there is the same medium here, so that's why the incident ray fall in the straight line, and these rays similar if these are parallel to the principal axis, and initially you say that that is incident ray parallel to the principal axis, so that's why these two are the alternate angle. And if I say these value is theta, so this angle also be the theta. And height of the object, these are the height of the object, and these are called h, that is the height of the object. And now here you see the triangle here, a triangle ABC triangle ABC, and you see that very carefully, tan theta that is equal to perpendicular by base. Okay, and if height equal to 1, okay, so and a small angle approximation and tan theta behave as a theta. Okay, so that theta that is equal to 1 by f. Okay, and that is called power. That is called power of lens. These are called power of lens. So tan theta is a power of lens. Okay, and you see that very carefully this diagram. If focal length is a higher, so if focal length higher, so theta is a very less. If theta is less, so power be the less. Okay, so now that's the concept. So the SI unit of the power, so that SI unit of power that is called diopter. Short form is 1D, and that is equal to 1 by focal length. So the SN is a meter. So the meter to the power minus 1. Okay. So 1 diopter equal to meter to the power minus 1 by 1 by meter. Okay. And you see that very carefully. If that theta is the length, okay, if a length is very thin, if the length is very thin, so it's a very thin lens consider. So actually this bending, the theta is very less. Okay, theta is very less. If I path the straight path, this theta is less. If theta is less, power also be the less. And here the convex lens also create a focus focal length on this side, and there's a focus on the positive x direction. So power plus positive power means, if you say that the positive power means the lens you use is called convex lens. It's called positive power. Okay, and these are called converging lens. So after emergent ray emerge from the lens, they are the converge at a point. Okay, so that's why these are called converging lens. Converging lens or convex lens if a power is positive. And if you consider that a concave lens, here there is the object here, after striking they diverge here. So that's why the focus is left side front of lens, that is a focal length, and this focal length be the minus, and that is equal to power equal to minus here. If power minus means concave lens, another name is called diverging lens. Clear? Now here I think the confusion will be clear. When someone says you have a positive power, means that you have positive power means the power is positive. So power positive means a convex lens. If someone says that is a power is negative, so now the glass we use that is a concave lens. Okay. Suppose focal length is suppose 20 centimeter. Okay. So what is the power? So plus 20 centimeter. So power is, obviously the power is positive 20 means the convex lens, and that 1 by 20 centimeter now convert to meter, divided by 100, and 100 by 20, and you get 5 diopter, 5D power. Okay, and that is a positive 5D. That's a very huge power. Positive power, that is very huge power. Okay, that is, if someone say that is a f minus 20, same calculation, power. So power be minus 5, so that is a minus 5D. Now use a concave lens. Okay, clear? What is the power and correlation between the power of positive power, negative power? Okay, I think I wouldn't doubt with the clear. If you have any doubt, please ask in comment section. Okay, I try to give the answer. And now we discuss next topic is discuss the combination of thin lanes in contact. If two thin lanes or 3, 4, more than one thin lanes are in contact, what will happen? Now the combination of thin lanes are in contact. Okay. Convex thin lanes. Okay. And now that's the principal axis. Okay, and here that is the object, that is incident ray fall on first lens. After striking, they actually passing to that point. Okay, and here the image first image create here after falling that first lens, that's an incident ray. These are the emergent ray. But in second lens, okay, in case of second lens, they actually, this is the first lens, that now these are the incident from second lens, this I1 dash and these back to, okay, clear. And here that is a U object distance, and there's a two lanes are in contact, and that is first is a V1 or V dash, that is called V1 or V dash, okay. And final image is from that point, that is the final image I, and that is V. Okay, now we apply thin lens formula here. From first lens, apply image from by lens 1, first lens, okay, and there's a first lens, that is a second lens, and that is 1 by V. V means V dash minus 1 by U, that is equal to 1 by F1 for first lens, okay, that is equation number 1. And now image from by second lens, so now that is a image 1 by V minus what is a incident, what is the U of that second lens, that is this distance from V dash is the U of the second lens, okay, that is the object distance of the second lens, that's why these are called V dash, the object distance of second lens, that is 1 by F2. Now if I added these two, now 1 plus 2, that is 1 by F1 plus 1 by F2, and you get 1 by V dash minus 1 by U and plus 1 by V minus 1 by V dash. So here V dash cancel, and you get 1 by V minus 1 by U, that is 1 by F1 plus 1 by F2, and you say that is equal to 1 by F, and we get the basic formula. Okay, so here you get the final formula is that F, the total focal length should be added here. It is F1, two lengths with the F2, second focal length, first lens focal length, okay, second length of focal length of second lens. If I add three, if there is a 4 length, so on, just be added here, So any number of lenses are in contact, okay, they are actually the sum, means addition of the thin lengths of focal length of 1 by F1, 1 by F2, any number of thin lengths in contact. If the several thin lengths, like focal length of that is 1 by F1, 1 by F2, that is 1 by F3, that is 1 by F4, and so on. Just the effective focal length, these are the effective, that is the effective or total focal length, should be added algebraically. So now the power, so 1 by F means the power, effective power, that is equal to 1 by P1, P2, P3, so on. Power should be added here. Okay, the sum of the equation of the algebraic sum of the terms of the right side of the convex for positive and concave for negative for similar magnification also. Okay, if there is a magnification, that is magnification is the total aim. So first multiplied second, there is a third, and so on. Magnification should be multiplied. Okay, so here actually the concept is that actually algebraic sum, okay, algebraic sum of the right side of the focal length part. Okay, if a convex for positive, keep in mind convex get positive result, okay, and concave get negative result. Effective focal length or effective power or effective magnitude, effective magnification. Okay. Now we discuss a refraction through a prism. Now the important concept, that is a refraction through prism. Okay, there I think clear. Okay, the thinness formula. If a two thinness are in contact, so what will happen? The focal length should be added, effective focal length. Okay, but actually reciprocal obviously. And power then normally should be added, and magnification also should be multiplied here. Okay, so refraction through prism, there is a prism. Okay, and these are the incident ray, and keep in mind the inside is the density 2, outside the density 1, that's the optical density. So density of inside the prism, that is much greater than outside. Okay, so light travel from rarer medium to optical denser medium. Okay, that is actually density, that is the optical density. Okay, and fall on this interface. So now draw a normal, and there is a refracted ray bend towards normal, and suppose the parallel to base of the prism. So now light travel from denser to rarer, that is a normal. Light travel away from normal. Okay, and if these two medium rho 2 and rho 1 be the same, then light travel straight apart, no deviation here. Okay, there is a no deviations. Okay, so that the deviation is called delta. This deviation is called delta. That angle is A, that is B, and that is C. The prism angle A. That is the incident angle I, and that is a refracted angle R1, and say the refracted angle R. Actually, that is a incident here R2 from this surface R2, and these are called emergent angle E. Now, if these two normal be added, normal to be cut this point. Okay, if I extend these two normal and they cut this point, and we will suppose the name that is suppose M N O P. Suppose M N O P. Okay, and you see that if A N O P is a rectangle here, and that is a rectangle of A N OP. So the opposite side of the rectangle, if I added these two angles, we get 180 degree. So that is means angle A plus angle O, we get 180 degree. Now similar type of concept, consider triangle NOP. If I added three angle of the triangle, we get also 180 degree. Suppose we added these three, means R1 plus R2 plus O at 180 degree. That is equation 1 and that is equation 2. That is 1 equal to 2, and we get A plus O, that is equal to R1 plus R2 plus O, and O with the cancel, and we get A equal to R1 plus R2. Okay, and now here the another triangle MNP, triangle MNP, and if I extend the NM side to up to suppose R, and this angle is the delta, deviated angle, the exterior angle, that is delta, that is equal to sum of two opposite of the two interior angle, these two angle here. So that angle P MNO MNO and this I, that is the vertically opposite. So I minus R1, and this angle similar like this angle emergent angle, if I, that is the vertically opposite, these two angle, that is E minus R2, we get this angle. So plus E minus R2. So finally delta you get, we get I plus E minus common R1 plus R2. And final expression I plus E, R1 plus R2 we get A, that is minus A, that is delta. That's the deviated angle. Delta. We derive that deviated angle. And now, if I draw a deviated angle versus incident angle, I draw a graph, delta versus I incident angle, and you see that if I equal to E, incident angle equal to emergent angle, that time you get a minimum deviation. So delta be the minimum. So minimum deviation, delta mean, that is I equal to E plus I. Now E replaced by the I minus A, and that is we get 2I minus A. So that is delta minimum. If 2I minus A, here another term, if these two are equal, so R1 and R2 also be the equal. So here, so R1 equal to R2, and you say that is a angle A, that is called R1 R2, and say that is R, say R, that is equal to twice R. So R equal to now A by 2. Now we draw a graph here, and the minimum deviation, draw a graph. That is a delta, and here with I. Now deviation is look like this. So okay, that's the minimum deviation at that point. Here this point I equal to E. There's a minimum deviation. When that increase the angle, so we get also increase the delta. If that incident angle is less than the emergent angle, also delta will increase here. But delta minimum, that's the delta minimum when I equal to E. Now we calculate the refractive index of the medium 2 inside the medium. That's refractive index Ri of medium 2 means N21. So N21 means N2 by N1. N2 means refractive index of N2 by refractive index of N1. So N2, that is from Snell's law, that is sin I. So I means here you get delta minimum plus A by 2, that is equal to I. So we write here delta minimum plus A by 2 by sin R. R means A by 2. Okay, now you get N2 by N1, and you get delta minimum plus A by 2, and that is, if I the small angle approximation, you get delta minimum plus A by 2 by A by 2. If you have a small angle is sin theta, theta here. Okay, if a small angle approximation, so by 2 be the cancel. So you get N21, that is equal to delta minimum plus A by A. Now cross multiply A N21 delta minimum plus A, and delta minimum you get A N21 minus A. Now A be the common, that is N21 minus 1, that is delta minimum. Okay, that's the minimum deviation when you know that refractive index of medium 2 and that prism angle. That time we calculate the easily from minimum deviation. Okay, do not depending on the draw a diagram or calculation for delta deviation or the calculating incident angle, etc. Just we know that the angle of the prism and the refractive index of the medium. Take an example. Suppose that delta minimum, suppose angle of prism is suppose 60 degree, and refractive index suppose 1.5 minus 1. So 60, 1.5 minus 0.5, so delta B there here is 30. Minimum deviation is 30 degree. Okay, that's a very easy calculation. So actually the concept is that is implied when we imply that a thin prism, actually thin prism, if I consider thin prism do not deviate light too much. Okay, if I consider thin prism, say do not deviate light. Okay, light too much actually. So that's our the concept today's class. If you have any doubt, please ask in comment section. I will try to give the answer. So next class we discuss another important concept that is called a microscope. Okay, the compound microscope, telescope, that's the optical instrument. That's very important for board exam. Actually, there is a important because the derivation. The derivation is very important. Okay, so today end the class here. If you have any doubt, please ask in comment section. Okay, thank you.